Okay, so today what we're going to look at arithmetic sequences still. So we saw that yesterday. Remember, that's a sequence where you add or you subtract the same amount every time, yeah? And we called that, remember, they were calling that in the letter D, that was the difference, okay? So that's what an arithmetic sequence is, and now we're going to use recursion. So we did have a look at recursion in the earlier lessons. So recursion's when they write it out like this. So they will give you the initial term. So if you want to say the initial or the starting term, so you write it out like that. So you'd say what T0 equals. And just for generic and just for basic, we're just calling it A. So if you were given down here, if we look down here on our little example, it said TO equals 24. So that's your A value. So A is the first value of the sequence, okay? Now, then when you see, when we write a recurrence relation, we have this little statement here. That is just a way, instead of us saying, you can get the next term, we write this, we use this symbol, okay? So, but you might just want to remind yourself, that's just the way of saying how you get the next term. So when I see this, so when I see a t little n plus 1, I know, right, they're giving me the rule of how I can get the next term in the sequence. And what I do is I take the term before and I then add the common difference or whatever it is, so we can see which is the D, which was what we looked at yesterday. So here when they say down here, so it says generate and graph the first 5 terms of the arithmetic sequence defined by the recurrence relation. So just so you're getting used to this, when you see recurrence relation, that's because they've written it like this, the TO, and they've written it in that language that way. That's what a recurrence relation is when they write it out like that. So they want me to write the first 5 terms of the sequence. So when you do that, and it's very important, so in year 12, they'll say, write out the first 5 terms using the recurrence relation. So what you have to do is you have to say, all right, T1 is bound by what essentially you're doing is you're saying it's T0 minus 2. So if you look at that, the one before minus 2. Okay, so then T1 is actually equal to 22. All right, so then they want the next one. So if you want T2, and you do have to show the working out. So it's 22 minus 2, so the one before, so 20. So we've got one, it wants the first 5 terms, so we keep going. T3 would be 20 minus 2, which is 18. And T4 would be 18 minus 2, which is 16. So the first 5 terms would be 24, 22, 20, 18, and 16. Okay? So it says the first 5 terms. If it had said T5, I'd have to do another one. But the first 5 terms, because 0 is counting as the first term, so the first one in the sequence. So there you go. Now, when we have, if it did ask us, and we've got to be careful, make sure we read all the question, it did ask us to graph it as well. So you don't have to go overboard, but what we're going to see is, so you'll have, we might just call the value of, we'll say what Tn actually is. And then over here is n. So that's we're going to have, so here we've got T0. Then we would have, then you just break it up. We had 1, 2, 3, and 4. So the first one, T0, now all I have to do is I'm just going to say it's up there. That's 24. Okay? And remember yesterday, if you're going an arithmetic sequence, what type of line will it be? straight line, a linear line. So really, just draw, because it's going downwards, isn't it? It's decreasing, okay? So what we'll just do, just draw a line down like that, and then you can just put the dots in, and you know that that was, when it was 4, it was 16. When it was 3, it was 18. And so I'm sort of doing it a little bit bit of a cheats way, but that's okay. And when it was 1, it was 22. Okay, it's just as long as it's a straight line, so you don't need to go overboard, just quickly draw it like that. Okay, so then it says generate the graph the first 5 terms of the sequence defined by this recurrence relation. So we've got T0, so T0 equals 7, and the way I get the next one is here. I take the one before, which would have been T0, and I add 3. So it'd be 7 plus 3, so T1 is equal to 10. And then you go T2 would be 10 plus 3, which equals 13. Then T3 will equal 13 plus 3. So you have to write all this working out. I know it's very easy maths in your head, but you have to write it out. That's what a recurrence, they want to see it stepped out like that. So we have to do the first 5 terms. So in the end, there we go. We had 7, 10, 13, 16, and 19. All right, and then we've been asked to graph it again. So this one, is it going up or down? Up, good. So just put up. So we started at T0, okay, and we go 1, 2, 3, 4, 5, and T0 was 7. So I'm just going to put a dot there, say that's 7, yeah, and then I'll draw a straight line up, and we only had to go to 4, didn't we? Sorry. I'll just do the 4 one. So, and then we'll just write, so when it was 4, it was 19. And then you can just pop in your other ones, okay? So our other ones were when it was 1, T1 was 10. So 1 comma 10. T2 was 13. T3 was 16. And T4, 19. There you go. Okay, so what happens is we could just keep finding the terms by recurrence. So that means I would have to keep going. And what if I said, oh, what's T20? You would just have to keep on adding 3 and 3 and 3. So what happens is that gets annoying. So we're not going to do that. So what we end up coming up with is we have this thing called the nth term. So that, and obviously we're going to have the nth term. So that means you use this to find any term at any time. So use this to find any term value. So if I was going to, ask what is T100, you don't want to have to be sitting there or clicking in your calculator, 100 times to get to it. So here's the formula of how you can find the nth term. So you can see here, there's that A value. So that's when you'll be given the first value, or you'll say if you want T0, yeah? And then that, obviously we've got here the D, and the D is that common difference. So remember, so the common difference, and it's what we're either adding or subtracting every time. So you remember the adding or the subtracting every time. So if you have a look here, so we're going to use it we're going to set up the nth term formula. So down here it says consider the recurrence relation. So when they told me T0, I know that's A. And when they told me this is how you get the next term, I know that this part here is that D value, that common difference. So if I was going to write out the nth term formula, I'm just going to write it generically. In this scenario, it would be 21 plus n times -3, because that's what D is. Okay, so sometimes you can write it like that, but obviously you might see it written like this. And that's because of algebra. We like to put the letter after. But it's not wrong if you leave it up there. So either one's right. So now I have a formula, a generic formula to find any term. So when they ask me to find T20, what that means, so here's my formula. Every time I see N, I'll put 20 instead. So it's going to be... so then when we do that, we go 21 minus 3 times 20. So what's that going to be? Okay, so -39. So you can see I got there quicker. So, okay, so let's do the next one. So we've got, consider the recurrence relation. So they're telling me A is 54. And you've got your D value is that +7. So because they want me to find T50, I will be much better off writing out the nth term formula. So when we are writing an arithmetic nth term formula, we write the initial number, which is 54, and then we're going to do plus n times the difference. So the D is 7, so it'd be plus 7 times n. I'm just putting the n second because that's how we like to have it. We like to have the letter after the number. But it's not wrong if you write it out like this, because our little generic, if you write it out as n times 7, that's okay too, okay? You're not going to get it wrong. All right, so now because we want to find out what T50 is, every time in that formula where I see an n, I will put a 50. Okay, so it ends up being 54 plus, what's that, 350? Yeah? So 404.